Question 4. The pH of a solution measures its acidity and can be determined using the formula pH equals negative log to the base 10 of C, where C is the concentration of hydronium ions in the solution measured in moles per liter. A lower pH indicates a more acidic solution. Okay. Concentration of hydronium ions in a particular type of coffee is 1.3 times 10 to the power of -5 moles per liter. Right, let's before we crack on, let's highlight our important info. So this formula here, pH is, that pH formula is going to be helpful. And specifically the number here, 1.3, the number of hydronium ions in a particular type of coffee. All right. Part A asks us to calculate, the pH of this type of coffee. So relatively straightforward here. We've just essentially got to substitute in this number here, 1.3. This is going to be our C. We just have to substitute that into our pH formula. So without further ado, let's do this. So pH is going to equal negative log to the base 10 of 1.3 times 10 to the power of -5. Okay, let's find out what that is. I'll bring this over. Okay. Oh, whoops. Negative log of 1.3 times 10 to the power of -5. You'll see, I'll put a third one in. You'll see you haven't had to put to the base 10 here because just log, the standard is base 10. So you can just put log. It'll be the same in your calculator as well. The standard log is base 10. And so there we have our answer. We'll go 4.886 ... and we'll round that to 3 significant figures. So pH is going to be 4.89, which is, funny enough, factually correct. The acidity of coffee tends to differ from varieties, but it ranges from around 4.85 to about 5.1. So that's cool, factually correct. All right, let's move on to part B. So a different unknown liquid has 10 times the concentration of hydronium ions of the coffee in part A. Determine whether the unknown liquid is more or less acidic than the coffee. Justify your answer mathematically. All right, so if this unknown liquid has 10 times the number of hydronium ions, what we can simply do is what we can call our new C. All right, so our new C for our new unknown liquid, we can say is equal to 10 times 1.3 times 10 to the power of -5. Now, you could probably figure out that that would just change this power here to being -4, which we can do. So times -4 to the power of -4. And then, we'll just lob that into our calculator and we'll find what the acidity will be. So I'm just going to copy this down here, change this 5 to a 4. Alternatively, you would have been absolutely fine just using this expression here. I just wanted to show you what would happen. Okay, and so let's calculate this. Quite nicely, we've still got that in our calculator, so we'll just change our 5 to a 4, and so that gives us 3.886. Okay, and so then, 3.886, and so to justify our answer, we can say that 3.886 ... is less than 4.886 ... And so we can conclude that our unknown liquid is more acidic. So if you're familiar with your chemistry and pH scales, ranges from 0 to 14, and acidic solutions or liquids are low numbers under 7, so water, tap water is 7, or neutral is 7, and then above is alkaline and below is acidic. But this is not a chemistry lesson, so we will just say therefore, so these 3 dots again, that means therefore the unknown liquid is more acidic. Okay, there is the answer.